Alright, today we're going to talk about multiplying fractions. Okay, it's going to be similar to what we did last time. So let's take a look at our... before we do an example, let's take a look at one fact here. You all know how to multiply fractions, don't you? So here's our first rule, one for the day. I mean, you knew this already. A over B times C over D ratio. No, don't ratio. How about, who knows what this gives you? Of course, let me pick somebody at random. How about... Brandon, what do you think? What do we get when you multiply A over B times C over D?
Is it AC over B?
Exactly, AC over BD, right? You just multiply the numerators together and the denominators together. That's how you multiply two fractions, right? And of course, since we have variables in the denominators, we have to write down the restrictions, don't we? Claire, what would the restriction be for this?
B or D not equal to 0.
Yeah, you gotta say it separately. B can't be 0 or?
D can't be.
Yeah, we don't mean that, you know, we don't mean that they can be both 0 at the same time. That's not what we mean, right? B could be 0, D could be 1 million, right? B could be negative 1 million, D could be 0. They could also be both 0 at the same time, but you know that's not always the case, right? At least one of them, if it's one of them is 0, right? Then the whole fraction will be undefined. Yeah, question?
Can't the restriction also be like B not equal to D?
No, not in this case. B could be B could be 1, D could be 1. It doesn't make the denominator go to 0, does it? Right? That's when, like, if B minus D is on the denominator or something, then you solve for one of the variables, remember? Then you will get B can't be B, right? If it was B minus D, yeah, B cannot equal to D. But this is not what we have. We have B times D. So remember, zero product property is kind of similar to that, isn't it? It's just saying the opposite of, right? Zero product property says one of them has to be 0. Now, one of them can't be 0 because it's on the denominator. You see how it's really similar to zero product property? Yes? So all these restrictions, you could think about it as zero product property. Just you don't want that to equal to 0. Right, guys? Do you guys? We'll do some like that. Okay. But last time we talked about, be careful of this sort of thing. Be careful if I have, you know, A plus B over A plus C. It doesn't equal to, it's not equal to A over A plus B over C, is it? We talked about this many times. What does it equal to actually? It does equal to addition of two fractions. Not this way, but it is actually an addition of two fractions. Does anybody know which two fractions you could add to get A plus B over A plus C? It is actually an addition of two fractions. Not this way though. You can't just separate it this way. It doesn't make any sense. We even gave you some examples for that, right? With some numbers, you know. Anybody know which two fractions we're adding together to get A plus B over A minus C? Tajwar.
A over A and B over C. No.
That's what I said. It's not equal to.
B
Let me give you a hint. It's actually equal to A over A plus C plus something.
B over A.
Exactly, B over A plus C. They have a common denominator. That's what it means, really. Right, guys? Isn't that how you get A plus B over A plus C? They have a common denominator. When you add the two fractions together, they have to have a common denominator, right? To add two fractions. So look, how do we get A plus B over A plus C? Well, that's really A over A plus C plus B over A plus C. Isn't that what it really means? Right? Do we have a common denominator? When you have a common denominator of fraction, how do you add fractions together? You just add the numerators with the same fraction. That's that common denominator. Right? So please don't get these confused, okay? Because then if you are confused with these, you're going to make a big mistake. Yes?
Simplify it. Can we cross out the A's?
Oh. I haven't thought of that one. Okay. So if I have A over A plus C, can I simplify the A's? Cross them out.
Yeah.
Say 1 over C.
Would it be 1 over C? No, it would not. Why can't we cancel out the A's together? Yes, Dana?
Because on the bottom it's addition.
Yeah, you have two binomials here. When you cancel something out, what are you really doing? Dividing top and bottom by the same number, right? For example, if you're canceling out A with this A, you're dividing top by A. So, okay, you get 1, that's fine. But when you divide the bottom, can you just divide that one term, or do you have to divide the whole term? The whole term. So it doesn't become A1, does it? I mean, it doesn't become C. It becomes 1 plus C over A, doesn't it? Right, guys? Does that make sense? Okay, so be careful. That's the same reason why you can cancel these a's out, right? Right, because you're doing the same thing here then. If you're canceling some things out from the numerator and denominator, right? You got to divide the whole numerator, right? And then you got to divide the whole denominator. Does that make sense? Yeah. Yeah. Why? How come it works here? For this one, we don't have any common factor. If there was, yeah, because it's multiplication. Because you get same thing over same thing. You see that in a minute. Okay. So here, take a look at example 1. So please be careful with these. Yes? Does that make sense? Don't get those confused. If you're not so sure, plug in some numbers to convince yourself, right, that this isn't true, right? Or you can cancel these out, right? A's and things like that. Okay. Take a look at example 1. Here. So we got 2/3 times 3 over 5. Of course, following the rule, it just means 2 times 3 over 3 times 5. Isn't that right? So if this is what we have, 2 times 3 over 3 times 5, could we rewrite this using commutative property of multiplication on the denominator? Could I write 2 over 3 times 5 over 3? I mean, I think 2 times 3 over 5 times 3?
Yes.
And then can I separate these fractions?
Yes.
Okay, who could tell me how? Okay, what would I write here? How about Kevin? How would I separate these two fractions as a product?
You would put 2 over 5 times 3 over 3.
Exactly, and that's what I would write. And let me hide this thing. Okay, then, class, what is 3 over 3? 1. And what is 1 times 2/5?
2/5.
Yeah, could we separate these fractions like this, right? 2, this is a multiplication, isn't it? 2 over 5 times 3 over 3. So if I have 2 times 3 over 5 times 3, we could separate these fractions this way, right? Now, what's 3 over 3, which is just 1? What's 1 times 2/5? 2/5. Does that make sense? Do you see how it's really different than if I had addition sign in the middle or something like that, right? This will be different. I have a multiplication sign. That's why we were able to do this. Or when you cross cancel like this, what are you really doing? Dividing top and bottom by 3's, right? But I don't want you to do it this way because people still cancel things out even if there's an addition sign in the middle. Does that make sense? You know what I mean? They just blindly, they see 3 on the numerator, they see 3 on the denominator. Even if there's an addition sign here, they would just cancel.
So you can't.
Yeah, you can't do that. That's wrong. You can only cross cancel if there's a multiplication in the middle. Okay? Think about it. Cross kind of reminds you of the multiplication symbol. So think about that way, right? So whenever there's an addition or subtraction like that, you can't cross cancel. The only time you could cross cancel is when you have multiplication. That's why I like this method better, where you rewrite it this way, because you can see it's going to be some fraction times another fraction. What's 3 over 3? Same thing over same thing as always. 1, right? So if you don't take this shortcut, if you just write it this way, you won't make that silly mistakes, right? People get into trouble because people just use a shortcut without really understanding what they're really doing. Question, Tachwa?
But isn't it easier if you just do 2 times 3 over 3 times 5? Like,
Yeah, I mean, you could multiply them out, right? Yeah, Tachwa was saying, why don't we just, doesn't this become 6 over 15? And we know how to simplify 6 over 15. Yeah, but then isn't this easier too? Like, cancel them out like this? Rather than multiplying these. I mean, these numbers are not so big, but what if you had like really big numbers and many of these, right? Then you want to cancel them out before you multiply the whole thing and then simplify. Yeah.
What do we do if like there's like 2a squared over 8? Can we like cross cancel that?
Yeah, we're gonna get there in a minute. Okay, but are we okay with this one for now? Okay. So it's kind of interesting. I mean, these are really simple questions, but right, you really have to understand what you're doing when you're canceling things out, right? Otherwise, you could make silly mistakes, right? All right, let's go to next example, and then I think it's going to answer your question, Tachwa. Okay. But actually, before we go to the next example, take a look at this. This is our second rule. Thank you. Okay, of the day. This works out really good. Okay, a over b to the n power. How would you write this? How would you simplify this? What does it mean, first of all? Really? To the n power? Jason, it means a over b times a over b. No, it does not mean a over b times it. It means you have an exponent m. It means multiply this base how many times? M times. So it means a over b times a over b times a over b.
You don't know how many times.
Well, how many times? We do know actually. How many times of a's? How many a's are you going to multiply on the numerator? M of these. That's what this exponent means, right? How many b's are you going to be multiplying on the bottom? So who could tell me? How about Patty? What would this become?
A over m. No, it's a to the m over b to the m.
Exactly. Doesn't this become a to the m over b to the m? We learned this, right, from previous section, the previous chapter. You guys remember that? Rules for exponents and so forth? So because you get a times a times a times a, you have m of these, right? And then you have b times b times b, you have m of those, right? Because that's what it means, right? A over b times a over b, m of these fractions are being multiplied. Of course, you need to write down the restrictions for this. What's the restriction for this here? B can't be 0. Did we write the restriction for the rule 1?
Yeah.
We did, right?
Yeah.
Okay. Yeah. B can't be 0. Okay. Good. So yeah. So knowing this, let's do an example 2 now. You have x over 3, the whole thing to the second power. This is very straightforward. So what is going to be multiplied twice on the numerator? X times x, and then on the bottom 3 times 3. So do you think it's a good idea to sort of use parentheses and use that rule 2? Because you know that x is going to be multiplied twice, and then 3 is going to be multiplied twice. Right? 3 times 3, x times x. So what's the answer, Camilla? X squared over 9. Very simple. Okay? Right? This is very straightforward. Do we need any restriction for this?
No.
You're right. We don't need any restriction. Lynette, how come we don't need any restriction for example 2? Yeah, there's no variables in the denominator, right? You guys, do you see that? Okay. And of course, we always have to check our original expression, right? Not the simplified one. You gotta look at the original expression of the denominator of the original expression. Of course, this one doesn't have any variables on the bottom, right? So we don't have to worry about the restrictions. Okay. All right. May I go on to example 3 now? All right. Here we go. Okay, so why don't you all try example 3, 12y over z third times z over 15. Okay, so how would you simplify this expression? You got a fraction multiplying another fraction, right? Go ahead, everybody try. I'll wait, okay? Do you think it's a good idea to rearrange these so that, you know, you can simplify nicely? Okay. Oh, so yeah, 12y over z cubed times z over 15. Okay, go ahead. All right, how about Carolyn? What would you do to simplify this product?
Combine both of them, so it can be 12y times z over z cubed times 15.
Oh, okay, yeah, okay, sure. You combine them, and then are you going to rearrange these so that it's how would you do it? What would you do?
12y
Uh-huh.
times z over 15 times z cubed.
Right. So I wrote it this way. I even separated it a little further. I said 12 over 15 times y over 1 times z over c cubed. Is that okay?
Yeah.
Yeah, right. Because then, isn't that nicer?
Yeah.
Because what is 12 over 15? Eugene, what do you get?
Get 4 over 5.
You get 4 over 5. Okay, then what about y over 1? Y over 1 is just what class? Y over 1. I wrote y over 1 because I'm going to, at the end, going to put everything together as a one fraction, right? Okay, then, last one, of course, Dakota. What's z over z to the third? Yeah, 1 over negative z squared. I mean, not negative. 1 over z squared. 1 over z squared, not negative. Right? You just have z on the top, you have z to the third, right? You cancel them out, right? So, what do we do? What do we get here when we, of course, Brianna, when you gather all these together, what do you get?
You get 4y over 5z squared.
How many people got 4y over 5z squared? Raise your hand. Good. Am I done? No, I'm not. Okay, Matthew, what's my restriction for this? That's right, z can't equal 0. Right, guys? How many variables do you have from the original expression on the denominator? Just 1, right? You just have z on the bottom. 15 and 1. Do we have to worry about 15 and 1 becoming 0? No. 15 is always 15. What's 1? 1 is always 1. Z, we don't want that Z to be 0 because then it will make the whole denominator go to 0. Does that make sense? Yes? Okay. Any questions? Alright, let's move on. Now let's take a look at example 4. Of course, do you think you need to know how to factor things? Yeah. Okay. So I got a minus 5 over a cubed minus 25a times a squared plus 10a plus 25 in parentheses. By the way, what is the denominator of that polynomials on the right? 1. So do you think it's a good idea to just write it as 1 underneath? Because, you know, you're multiplying two fractions and you may say, wait, there's nothing on the denominator. There's that invisible 1 there, right? Okay, so go ahead, everybody try to simplify this product. Okay, of course, do you think it's important to be able to factor these things? Yes, okay, go ahead, everybody try. I'll wait. And of course, you could help each other out. Okay, go ahead. So, let's see, who could help me how to do this problem? Of course, we're going to have to factor these. Let's see, who should I? Carly.
Hi.
What should I do?
I got the GCF of a cubed minus 25.
Good. You looked at the denominator of this first fraction and then you said GCF is a, so you get a times a squared minus 25, correct? And you notice that it's also a difference of 2 squares, isn't that right?
Yes.
So that's really important to note. Every time you see 2 terms, right? Of course, you should always look for GCF, which is what we did. Every time you see a polynomial with 2 terms and of course subtraction in the middle, you gotta check and see if it's a difference of 2 squares, right? All right. What about that trinomials on the top? What can we do with that one? Samuel Park, what do you think? What do I do with this trinomial on top? Yeah, you factor it. What does it factor to? Were you able to factor this? Yeah, it turns out it's a perfect square trinomial, isn't it? Same binomials together. Anyway, okay, so are we done with this? Not quite, because look at the denominator of the first fraction. Tajwar, what's a squared minus 25? We could actually factor that out more, can we?
Yeah, it's a plus 5 and then a minus 5.
You're exactly right. It's difference of 2 squares, so this is what we get. And of course, we're going to rewrite this, because I noticed that, oh, there's a minus 5 on the numerator, a minus 5 down here, a plus 5, a plus 5. And do you think it's a good idea to keep things in parentheses like this? Yeah, that's the whole factor, right? So I'm going to rearrange this so that things will cancel out. Spencer, what do you think I should do?
I took the a plus 5 and the a plus 5 and put it over where the a minus 5 is, and then I separated it to a minus 5 over a minus 5 and a plus 5 over a plus 5 and a plus 5 over a.
Exactly, that's what I would have done. Okay, so you separate them this way, right? Because you sort of line them up because it's all multiplication. Look, right? You see between each of these factors, right? It's all multiplication. So what's a minus 5 over a minus 5, class? 1. What's a plus 5 over a plus 5? 1. So it just simply becomes, this whole thing simplifies to, Royce, what does it become?
A plus 5 over 1.
Yes. Over 1?
Oh, a.
Over a, not 1, right? A plus 5 over a. And why do you think I highlighted these denominators from the original expression? Because, anybody see why I did that? Yeah, to get your restrictions. Because do I look for restrictions after I simplify or before I simplify the whole thing? Before. I gotta look at the original expression, right? Of course, it has to be factored in order for me to see what the restrictions are. So, of course, this becomes, how many people got a plus 5 over a, and then there should be 3 restrictions, right? Because there were 3 factors on the denominators, right? It's kind of like zero product property, isn't it? When will a be 0? When a is equal to 0. When will a minus 5 be 0? When a equals to 5. When will a plus 5 be 0? When a is equal to negative 5. Do you see how I get 3? How many people got 3 restrictions here? Did anybody put down only 1 restriction? A can be 0?
Yeah.
Okay. And do you know why you did that?
Yeah.
Why? Because?
I know why I should have put more.
Yeah, because I bet you only looked at the simplified expression, right? Remember? Whenever you write down the restriction, we always look for the original expression. That's what you need to look at. Not after you canceled everything out. Does that make sense? That's why we have 3 restrictions. If you only looked at the simplified one, you would have just written this down and would have gotten this wrong. Does that make sense? Yes, sir.
What do you mean by the original? Because like when you say original, I think you mean like when you very first start out with.
Oh, right. You're right. Original meaning, yes, this very first one, but, you know, in order to know what your restrictions are, after you factor out the denominators. So maybe I should say the expression before you cancel everything out. That's what you need to look at. Is that okay? That's what I mean by original. But yeah, it has to be a factor, otherwise you don't know what your restrictions are. Is this okay? Any questions? All right. All right, so let's look at the next one then. Example 5, you have 4y over z to the 3rd power times 3z over 8y. Okay? So we're going to use that rule with that exponent. So can somebody tell me what would the first fraction, 4y over z to the 3rd, what would that be if I were to raise to, you know, if I simplify that? In other words, if I get rid of the parentheses, what would I get? One person knows? How about Samuel? Lee, what do you think? What will 4y over z to the 3rd be if you get rid of that parentheses? Over? Exactly right. It'll be 4 to the 3rd, y to the 3rd over z to the 3rd. And then, of course, 3z over 8y is just the first power, so you could just get rid of that parenthesis. Right? Some people told me that it's not going to be 4 to the 3rd, but it's 12. Is that right? Does it become 12y to the 3rd? Do I just multiply 4 times 3? No, it means 4 times 4 times 4. Okay, so please do not write down 12y to the 3rd. I cannot tell you how many times I've seen that. Right? It means you multiply 4 3 times. It doesn't mean 4 times 3, does it? Because it means 4y over z times 4y over z times 4y over z, right? Whenever you're in doubt, you should
Write it out.
write it out.
Write it out.
So you know that it becomes 4 to the 3rd, not 12. Yes? Okay, go ahead now and simplify. You should all be able to simplify this. I'll wait. Okay, go ahead. Everybody try. How about, yeah, let me pick, let's see. Jason,
Yay.
what do I write next?
Oh. For the left side, you
Yep.
write 64.
Yep.
I switched the 8y to z3.
Well, just tell me what, okay, you get 64, right? So I just wrote that first.
Yeah. And
Okay, then what do I do?
I switched the 8y with the z3 on the denominator.
Yeah, tell me what to write.
So you get 64y cubed over 8y times 3z over z.
Yeah, I sort of did that. I actually put all the numbers together. Is that okay? On the ones. That's the same thing. Now, how come I didn't multiply 3 times 64? Because I could do that, but right. And not only that, how many times is 8 going to 64?
8 times.
Isn't it easier to divide that first, then multiply? You could multiply 3 times 64 and then divide by 8, but you know, why not just simplify before? Isn't that easier? Because everything's multiplication. Okay, so who could tell me what I get? How about Lindsay?
You get, well, I got my answer, 24.
24, yeah, right. You're right.
24 y squared over z squared.
That's right. Because what's y? So, okay. So take a look at, don't we get 24 y squared over z squared? Because what's y cubed over y? Well, that just gives you y over 1. What's z over z to the second? I mean, z over z to the third. 1 over z to the second. Did anybody put z to the second over 1? That would be wrong. We have more z's on the denominators, right?
Yes.
For some reason, whenever people get something, they always put things on the numerator. That's not always true. You have z over z to the third, so therefore you divide top and bottom by z, you get 1 over z to the second. I'm not done, am I? Okay, hold on. Oh, hold on. Yeah, okay, hold on. So, yeah, hold on. Let's see. Okay, Michael, how many restrictions do you think we'll get?
I think you'll get 2.
2, you're right. Because before we cancel everything out, right? This is where I even highlighted it here. So, what are your restrictions? There are 2 of them. Chuck, what are the 2 restrictions that we get from this?
Z can equal 0
Is that the only one?
and y equals 0.
And yes, y can't be 0. There are 2 of them. How many people wrote down both of these restrictions with the right answer? Very good, very good. Do you see why we need both of these?
Yes.
Always look for the restrictions before you cancel things out, okay? Jason, and that's what I meant by original, right? Expression. Okay, so does this make sense? Do you think you could do these, something like these, for your homework tonight? Because you're going to see a bunch of these. Okay, all right, good.